Dang, bro, you got that calculus book?
Yeah, man. I'm trying to get this young calculus class out the way. I'm working on derivatives right now.
Derivatives?
Well, they cheap.
Yeah, it's stupid. I don't even know how to do them.
What's that about?
I don't know. So I'm trying to figure out.
Man, I heard about them derivatives.
Hey y'all, what y'all talking about?
Derivatives.
Oh, you know her too?
Do you know what it is?
No, she looks scared.
Oh, it's pretty simple. A derivative is basically like finding the slope or the rate of change. So like anytime you hear like derivative, you're just gonna find the slope or the rate of change.
Oh, that's dope. What's your name?
Oh, I'm Cassandra.
What's your name?
Courtney.
So today we're going to take the derivative of secant x plus tangent x, secant x minus tangent x, and we're going to use the product rule. The product rule states, leave the first one, take derivative of the second one, add them, keep the second one, and take derivative of the first one. So we have f prime, keep the first one, take the derivative of the second, is secant x tangent x, minus secant squared x, plus, we're going to keep the second, and take derivative of the first, secant x tangent x, plus secant squared x. So now we have to distribute all of this. So that's going to be secant secant, which is secant squared x, secant tangent, okay, tangent and secant. Make sure you put your plus sign. So this whole thing you should get from you distributing each one. Now we have to see which ones are like terms in this matter. So first, we're going to do secant. See, we have a secant squared x tangent x. That's a like term. So we have it right here, and we have it right here. So we cross it out, as you would do on that side. Now let's see if we have a secant cube x on the other side. We have one right here, and we also have one right here. We're going to cross that out. We're going to do this for each one of these terms. So we see we have a tangent x, secant x, tangent squared x. So as we can tell, we both have it on both of these sides. Cross and cross. Last, tangent x, secant squared x, and we have it on this side. So cross, cross. Now I know you're saying we're doing all this work to get the answer 0. Yay, we did it! So the question says, find an equation of the line tangent to the graph f of x equals 3 over 1 minus 7x at the point 1 and negative 1/2. So what we're going to do, we're going to pull this out. We're going to focus on this right here. We're going to pull it out. Take the derivative of that first. So we all know you cannot have this at the bottom. So we're going to pull it to the top. Which is going to equal 3. So after doing the power rule, we're going to use the chain rule. The chain rule just says, it just tells you to keep this and take the derivative of just this right here. So we're going to do d over dx. So we're just going to go backwards backwards a little bit. It's not going to change your answer. We're just going to go backwards. So we, like I said up here, we're going to do 3 times negative 1 is going to give us negative 3. So now we're going to plug in. So we're going to keep the y minus 1/2 equals m, which is your m that you found over here, which is 0.583. Once again, I said that's in the decimal form, so you can always put that in the fraction form. Parentheses, keep the x, and your x value, x1 is minus 1. So 2 negative equals a positive. Y plus 1/2 equal, distribute 83x minus 0.583. We're going to minus the 1/2, but we're just going to change it to 0.5 since this is in the decimal form. So 0.5, that's the same as saying 1/2, 0.5. And that will give you negative 1.083. Bring this down. So y equals 0.583x minus 1.083. That is the equation that you are going to use for this. Explain what is done if you are finding a derivative of a radical function. So a radical function simply is radical over x, for example. So I'm going to give you another example of how to find the derivative of a radical function. So say we have radical square root 7x to the second power. So this is an imaginary 1 right here. So we're going to f prime x, excuse me. So we take this imaginary 1. First of all, it comes out of the radical root when you're finding the derivative. So you're going to keep 7x, take this imaginary 1, and place it over 2. So that is how you take the derivative out of a radical function. So the question says, explain what is done if you are finding the derivative of a function that has a variable in the denominator. So I'm going to give you an example. Example would be, we're going to say 1 over 2 minus x. So we know you cannot have a variable in the denominator. So we're going to just bring it up to the top. Keep the 1, parentheses, 2 minus x, and bring it to the negative power.
Okay, so today we are going to be finding the slope function, and basically when we refer to slope, we're also referring to the derivative. So what we're gonna do, we're gonna be using the quotient formula since this is division. So what we're gonna do first, we're gonna label our 2 terms. So we're gonna label this high, and this one we'll call low. So what we're gonna do first is write out our formula, and the quotient formula, well, the quotient rule is low d high minus high d low all over low squared. So what we're gonna do is we're going to keep this low. So it's gonna be 3x minus 2, and take the derivative of high, which is 2x plus 5, then subtract that from high, so 2x plus 5, then we're gonna take the derivative of low, which is 3x minus 2. And we're gonna put this all over 3x minus 2 squared. So when we do this, let's say you're gonna keep this. So now we're going to take the derivative of 2x plus 5. So the derivative of 2x plus 5 is just going to be 2. And 5 is a constant, so that means that the derivative of 5 is just 0. You don't even have to add that. Then you're going to subtract 2x plus 5, that stays the same. And we're going to take the derivative of 3x minus 2. The derivative of 3x minus 2 is once again 3. You're going to, minus 2 is also a constant, so it's just 0. You don't add that. Now we're going to go down here to the bottom. This stays the same at all times, so do not change it.
I can't even take a picture.
Right now we're at 3x minus 2 times 2 minus 2x plus 5 times 3 all over 3x minus 2 squared. So when you multiply that, you're going to get 6x minus 4, and you can put this in parentheses, minus 6x plus 15, all over 3x minus 2 squared. So there's an imaginary 1 here, so your answer is going to be 6. Well, you're still working it out. Then when you do this distribute, you're going to get negative 6x minus 15. And when you work this all out, your answer is going to be negative 19. Well, actually, this should still be over 3x minus 2 squared. And when you combine like terms, you're going to get, well, these two cancel out. And when you combine these two, your answer is going to be negative 19 all over 3x minus 2 squared. Secant 4 minus the 4th root of x to the cubed. So what we're going to do first, we're just going to rewrite the problem. And when you do this, well, let's just rewrite it first and I'll explain. Okay, so this x to the 5th, it does not belong there. So what we're going to do, we're going to bring that up to the top in the numerator, excuse me. So you're going to put f prime, since we're taking the derivative, and it's going to be 2x minus 5. The derivative of negative x to the 11th, you're going to bring this 11 in front and subtract 1. So it's going to be a negative 11, I'm sorry, it's going to be negative 10. Yeah, I was actually right. Negative 11x, and when you subtract 1, the power is going to be 10. This is a constant, so it's just going to be 0. You don't even have to add it, but we'll add it just because. This is going to change to x 3 over 4. So as we continue to work here, I'm going to do, since we have everything all laid out, sweet as pie, we're going to bring this up to the front. So it's going to be negative 5 times 2x minus 11x to the 10th. You don't need to add a 0, so it's minus x to the 3, 4 minus 1. So when you work this all out, it's going to be negative 10x. Since it's a negative 5, you always subtract 1 from your power. So it's going to be 6, and then minus 11x to the 10. And when we subtract this, it's going to look like this, 4 over 4 minus 3 over 4. So your answer is going to be minus x to the negative 1, 4. And usually when you're solving everything out, you usually put the highest exponent first. So your final answer is going to be negative 11x to the 10 minus 10x to the 6 minus x to the negative 1, 4. And that is how you do this problem. Here's an example of the product rule. We have 2x plus 5 times 3x minus 1. So this is going to be u and this is going to be v. Let's follow the product rule, keep this the same. So we're going to make this 2x plus 5, and when we say the derivative of v, this is going to just be 3, and this is 0. You don't have to add a 0. So when you multiply that, well, let's do this side as well. So when we do this side, we're adding once again. So we keep v. This is going to be 3x minus 1. And then we're going to multiply that by the derivative of 2x plus 5, which is just going to be 2.